Hello everyone, this is another video on atomic and molecular physics. We will be discussing more questions from this chapter. Okay, this will be question number 20 in this series. Fundamental band for CO molecule is centered at 2143 centimeter inverse, and the first overtone at 4259.6 value of anharmonicity constant. So, what is a fundamental band? See, fundamental band. Fundamental band is when for V is equal to 0 to V is equal to 1. First overtone First overtone is how much? V is equal to 0 to V is equal to 2. We know the formula EV is equal to V plus half omega E chi E, sorry, omega E minus V plus half whole square omega E chi E. Okay, where chi E is your anharmonicity constant. Okay, so for V E0 is equal to how much if I calculate? Half omega E minus 1 by 4 omega E chi E. E1 if I calculate it would be 3 by 2 omega E minus 9 by 4 omega E chi E. And if I calculate E2 that will be 5 by 2 omega E minus 25 by 4 omega E chi E. So now what will I do? I will do for E 0 to 1, that is your what? Fundamental band. If you subtract it, it will be omega E minus this one is 2 omega E chi E. Exactly, yeah, this will be what? E0 to 2 first overtone, right? This is fundamental. This is first overtone. 0 to 2. 0 to 2 is how much? If we subtract it, omega E minus, sorry, this one, 2 omega E minus, this is 6 omega E chi. Now what is given? First fundamental is given, first overtone is given. So what will I do? I will take the ratio. Okay. Omega E minus 2 omega E chi E, 2 omega E minus 6 omega E chi E is equal to how much? Is equal to 2143 by 5 to 4 to 5 4 to 59.7 7. Okay, so here if I take omega E common, 1 minus 2 chi E by omega E common, 2 minus 6 chi E, that will be 2143 by 4 to 59.7 cancels out. Okay, minus 2 omega E by 2 minus 6 omega E chi E is equal to this much, right? So we just have to cross multiply here. Okay, if you do the cross multiplication, you will get the answer for pi. Okay, that is the answer for this. Question number 21. Substance was a Raman line at 4567 angstrom when exciting wavelength is used. Wavelength of the Stokes line for the same substance when exciting line if this is used. Okay. So the Raman line that is given is actually what? Stokes line. So this is your Stokes, lambda Stokes is 4567 angstrom. Okay. Then exciting wavelength lambda x equal to 5 angstrom. So what is del nu is equal to what? 1 by lambda x minus 1 by lambda Stokes. Okay. From here you will be able to get the del nu value. That is what? For example, this is this one. This is the exciting one. So plus del nu if I add, I will get anti-Stokes. Minus del nu if I do, I will get Stokes. Okay, get it? Right. So this one you will get it del nu. After that, what will you do? In the next step, you will use this exact del nu for 1 by lambda exciting. What is the exciting in the second case? Exciting line is 4047 minus lambda Stokes. From here, you can calculate lambda Stokes. You put the value of del nu here, and this is already there, so lambda Stokes you can find out. Dash lambda Stokes. Got it? This is the process. Calculations you have to do. If I do everything, then okay. Next question, number 22. The rotational constant and the fundamental vibration frequency of HBR are respectively rotational constant 10 centimeter inverse, vibrational frequency, fundamental vibrational frequency, that is omega A, suppose. Okay. The corresponding values for dBr are approximately dBr. We know B is equal to what? H by 8 pi square IC, isn't it? That means H by 8 pi mu r square C. So H B is kind of inversely proportional to mu, isn't it? The reduced mass. So B1 by B2, BHBR by B dBr will be how much? Mu of dBr by mu of HBr. So will it? This is hydrogen. This is deuterium. So this should be only two, right? Right. So BHBr by B dBr will be two. Hmm. What is BHBr? BHBr is 10. So 10 by B dBr is equal to 2. So B dBr will be how much? 5 centimeter inverse. That's the answer, alright. So this is B dBr. Now corresponding values, okay. Now also frequency is asked. Again, if you see, omega is inverse like proportional to 1 by mu. From that you can calculate omega 1 by omega 2 is equal to root over of mu 2 by mu 1. Again root 2, this is root 2. Okay, omega 1 is how much given? 2000 by omega 2 is equal to root 2. So omega 2 will be how much? 2000 by root 2. That will give me 1414 point something else. Okay, this is the answer. Okay, so which option will be correct? Option D. Right. These are gate questions, not net. These are gate level questions only. Net other question will be a bit lengthy. It won't be directly. This is a gate level question. Next question, question number 23. In pure rotational microwave spectrum of XY molecule, the adjacent lines is separated by 4 centimeter. The molecule is radiated by radiation of this one. Okay, I have to write down in a pure. Take your time if you can solve it. You can pause the video. In a pure rotational microwave spectrum. Okay, what happens is the separation between adjacent lines is how much? Separation between adjacent lines is equal to how much? 2b. Okay, so 2b is equal to 4 centimeter inverse. So b is equal to 2 centimeter inverse. Okay. Hmm. So yeah, molecule related to this one. So Stokes line is up. That means, for example, this is your exciting line. What is the Stokes line? Stokes line is here. What is the difference? 6b. Okay, 6b on this side, 6b on this side, anti-Stokes. So 6b will be how much? 6 into 2, that is 12 centimeter inverse. What is this line? This line is 3, so 30,000. So 30,000 minus 12 because it's the left side. This will be what? 29988 centimeter inverse. Got it? Yeah? Yeah. So option A will be correct. Next question, question number 24. The anharmonic diatomic oscillator has frequency this much. Dimensional constant of dimensional constant of this one. Dimensionless anharmonicity constant of 1 by 30. The diatomic molecule is made to dissociate by supplying energy equal to the depth of the potential with the minimum relative kinetic energy of the ejected atom. So anharmonic diatomic oscillator has a frequency. The frequency is given. Okay. Anharmonicity constant chi e 1 by 30. Okay. So the minimum kinetic energy formula is what? 1 by 2 omega e minus 1 by 4 omega e. This is the formula. Okay. 1 by 2 into 3000 minus 1 by 4 into 3000 into 1 by 30. 100. Hmm. This is 25. 1500. So answer is how much? 1475 centimeters. Got it? This is the formula you have to remember. Kinetic energy. Hmm. Okay, next question. Okay, the bridge spawner plot between del G is equal to this is for a CO is straight line with slope of minus 14 centimeter inverse and intercept for example C 2170 centimeter inverse. So the approximate value of dissociation energy have to find out of CO molecule is okay. So okay. See the equation actually is del G is equal to omega E minus 2 omega E chi. Okay. Omega E, this will be I think E plus half. E plus half. So like mm, sorry, let's see. Del G will be omega E minus 2 omega E chi E with E plus 1. This will be the equation. Okay. So if you compare it to y is equal to mx plus c, so what is your c here? C is your omega E mx. This is your mx, isn't it? So m is how much? Minus 2 omega E chi E. X is the v plus 1. Okay. X is a v plus 1. So c is equal to omega e. Slope is minus, sorry, c is your omega e. That means intercept is, so omega e intercept is how much? 2170. Now slope is this much, minus 2 omega e chi e. What is slope given? Minus 14. So omega e chi e is how much? 7. Okay. Omega e chi e is how much? 7. So omega e chi e is equal to 7. Omega e is how much? 2170. Chi e is equal to 7. So chi e is equal to 7 by 2170. Right. So now dissociation energy formula. Dissociation energy. V is equal to what is the formula for omega e by 4 chi e. This is the dissociation energy. So omega e is how much? Omega e is omega e is your what 2170 by 4 into 7 by 2170. So if you calculate this, you will get your answer. Alright, did you get it? how to use this equation. Yeah, this was your what? Question number 25. Now, question number 26. The frequency difference between two adjacent modes in an optical resonator having a cavity of length 1 meter. Okay. So, frequency difference, there is a direct formula for this. Frequency difference between two adjacent modes in an optical resonator is, what is it? Del nu is equal to c by 2t. Okay. Where c is the what? Speed of light by 2t. D is 1 meter, right? So 1.5 into per 8 hertz. If I can write it 150 into 10 to the power 6 hertz, I can write, right? So this is a what? 150 megahertz. Got it? This is the answer. Okay. So these were some of the questions from this Raman spectra chapter. Okay. You can give a heading this one as Raman spectra. 7 questions we did from Raman spectra. We will do more questions, of course. Uh, okay. Yeah. Keep tuned with me for upcoming sessions where we will be discussing more questions. Okay. Thank you.